Okay. Oh God, it seems I've forgotten my matchbox. That can be a big problem in a place like this in the wild. But don't you worry, science will come to rescue. There. That's my matchbox. All right. There. Science to the rescue again. Wondering how I did that? Let's get to the studio and find out exactly how. Hello, I'm Shalerm, and with me you will learn the fundas behind physics and the tricks behind scoring those crucial marks. Today we will discover an amazing device. The reason why it is so amazing is that despite its simplicity, it has numerous and varied uses. Today we will be studying the spherical lens. We will go over lenses and how they work, spherical lens and its types, namely convex and concave lens, some important terms related to spherical lenses, converging and diverging lenses, and of course we will find out how to bag those marks in exams in our special section, Exam Decoded. A magnifying glass, like this one. A wonderfully simple optical instrument with just a single lens. Yet one of the most important inventions of our times, I must say. It is the principle behind this humble lens that today enables us to see distant stars as well as into the human body in great detail, maybe through the microscope. But before we start unraveling the mystery behind the lens, let's recall a property of light, refraction. You remember that one? That says that when a ray of light passes from one medium to another medium, there is bending of light at the surface separating two media. And this phenomena is known as refraction of light. Now when a ray of light passes through a transparent slab with parallel faces, the ray of light refracts twice. While both the incident and emergent rays are parallel, the rays just get shifted sideways. But let's just tweak it up a notch and see what happens when light passes through a medium bound by curved surfaces. To find the answer to this one, let's watch this experiment. We start with a stiff piece of paper, and in this we cut two slits like this. Now with that done, let's fix our paper on the side of a cardboard box with a window cut out in it. With this done, let's remove the opposite side of the box and shine a light on the slits. See how the light travels. But what happens when we put this tumbler full of water in the path of the rays? The light rays bend. Notice how the direction of rays changes after refraction. We make use of this phenomena of refraction at curved surfaces to make lenses. Now we've been talking about lenses for some time. So before we move on, let's know what are lenses and their various types. A transparent material bound by two refracting surfaces, of which at least one is curved, is called a lens. Now if the curved surface or surfaces of a lens are spherical, the lens is called a spherical lens. Simple enough, isn't it? Okay, so let's then move on to studying spherical lenses. That is, two types of spherical lenses: convex and concave. Incidentally, it was a convex lens which I used to start a fire at the camp. First, let's talk about the physical appearance of these lenses. A lens that is thicker at the middle than at the edges is called a convex lens, while a lens that is thicker at the edges and thinner in the middle is called a concave lens. Remember this well, because this is the basis of all that we will study from lenses here on. Lenses are classified by the curvature of two optical surfaces. A lens is biconvex, double convex, or sometimes just called convex if both surfaces are convex, that is, thicker in the middle and thinner at the edges. While a lens with two concave surfaces is biconcave, double concave, or sometimes simply called concave, that is, thicker on the edges and thinner in the middle. Remember that. Now, if one of the surface is flat, the lens is plano-convex or plano-concave depending on the curvature of the other surface. A lens with one convex and one concave side is convex-concave or meniscus. It is this type of lens that is most commonly used in corrective lenses that are used in, let's say, spectacles. Both convex and concave lenses can be made very thin, and these lenses are called thin lenses. Now let's study some important terms related to thin spherical lenses. I think you should note down these terms as we will be using them pretty often. The geometric center point of the lens through which any incident ray passes undeviated is called its optical center and is represented by O. This is the same for both convex and concave lens. Imagine a spherical lens as a cutout part of a solid sphere, like on the screen. The center of the sphere is called center of curvature of the lens. Since the lens has two curved surfaces, let us consider two spheres with centers C1 and C2 respectively. The distance of the centers of curvature from the optical center is called the radius of curvature R of the lens. Let us now imagine a straight line passing through centers of curvature and the optical center. Now, this line is called principal axis of the lens. The aperture of a lens is the diameter of the circular edge of the lens. Here, AB is the diameter of the circular edge, which represents aperture of the lens. Now that brings us to a short break, but before I leave, I have a question for you. Do you know who made the first convex lens? Well, the answer waits on the other side of the break. So until then, keep watching.